is fine. I'm just waiting for the students to enter into the class. At present, we have 29 students. So I think we can just wait 1 or 2 more minutes and then we can start our class. Last time we have studied about the construction of the Mohr circle. So today we are going to do the numerical and then we will study about the absolute maximum shear stress. So that's with that our chapter will be finished. Okay, so I'm just waiting for the students to come and then we can start our numerical problem. Guys, should we start the lecture?
Yes, sir, we can.
Okay, Bismillahirrahmanirrahim. Let me start the recording. Bismillahirrahmanirrahim. Let's start with our today's lecture. Today we are going to do a numerical problem related to Mohr circle. So last time we have studied how to construct a Mohr circle. So today we are going to do the numerical. So example 9.7, we are not going to do it because that is in FPS system. Okay? So this example, it's in FPS system. But what we will do based on the same data, which is for example 9.8, the same data we will use it to calculate the principal stresses, orientation of the principal planes. So let's start with our example 9.8. Remember one thing, the practice problems which you guys will do, those practice problems will also be related to SI system. We are not going to do FPS, so we just want to focus on one system which is commonly being used. So example 9.8, the state of the plane stress at a point is shown on the element. So this is our figure. So this figure data is exactly the same which we have used earlier to calculate the principal stresses, maximum in plane shear stresses, orientation of the principal planes, orientation of the shear plane, using what you say equations. Now we are going to repeat the same data, repeat with the same data, and we are going to draw the Mohr circle. And in the Mohr circle, uh, we will calculate principal stresses, maximum inclined shear stresses, orientation of the principal planes, orientation of the shear planes. Then we will also calculate uh, transformed normal and shear stresses. Okay, so let's start. So the data is that you have a normal stress sigma y, that is 90 megapascals, and it is pointing towards positive y-axis, so it is positive. So 90 megapascals positive. Then you have normal stress sigma x. Sigma x, it is pointing or directed towards negative x-axis, so it is minus 20 megapascals. Then you have the shear stress. Then you have the shear stress, which is 60 megapascals. So tau xy is equal to 60 megapascals because the vertical component is pointing towards a positive y-axis, so it is positive. ठीक है जी? Now you have the plane stress state data. So now to start with the construction of the Mohr circle. Now to start with the construction of the Mohr circle, what is the first step? First step is we should calculate the coordinates of over point C. Point C is over center point of the Mohr circle. So first step is we need to calculate the coordinates of point C, and to calculate the coordinates of point C, whose coordinates are average normal stress and zero shear stress. So we have to calculate average normal stress. So please calculate the average normal stress. Please calculate the average normal stress. Please calculate the average normal stress and let me know the answer. 35 megapascals. So average normal stress is 35 megapascals, sigma x plus sigma y. Sigma x is minus 20 megapascals, sigma y is 90 megapascals. So the average normal stress is 35 megapascals. So the average normal stress is 35 megapascals. So what will be the coordinates of point C now? The center of the Mohr circle, C. ठीक है जी? So what are the coordinates of this point C? So coordinates of point C will be 35 and 0. Is this fine? The coordinates of point C will be 35 and 0. The coordinates of point C will be 35 and 0. ठीक है जी? Is this point clear? Now, next thing is you need to your reference point. Over reference point is point A, and the coordinates of point A are sigma x tau xy. Reference point A. Coordinates of the reference point A. So please let me know what are the coordinates of reference point A. What are the coordinates of reference point A?
Sir, minus 20 and 60.
minus 20 and 60. Okay. Now next thing is minus 20 and 60. Next thing is we need to calculate the radius of the Mohr circle, or you can say the resultant. If you recall, the formula for the calculation of the radius or the resultant is under root sigma x minus sigma y over 2 square, sigma x minus sigma y over 2 square plus tau xy square. So please calculate the radius, or you can say the resultant. So please calculate it. R. Sigma x minus sigma y over 2 square plus tau xy square and the under root of this. So what's the value we are getting? G. What's the radius or resultant? In general, up to one decimal place is okay. 81.4 megapascal. So resultant or radius of the Mohr circle is 81.4 megapascals. ठीक है जी? So resultant or radius of the Mohr circle is 81.4 megapascals. Fine. So now you have the coordinates of point C, which are 35 and 0. You have the coordinates of point A. Guys, remember this, in this data, sigma x was minus, so that's why your coordinates are minus 20 and 60. If in the other question, if it is positive, you will take positive. So whatever is the value and the what you say sign of sigma x and tau xy, you will take as it is your reference point A. Then resultant or the radius is 81.4. So now let me show you the figure. Okay, so this is first of all draw the axis. Okay, the first step is we have to draw the axis. Okay, so please draw the axis. First step is we have to draw the axis. First step is draw the axis. On the vertical axis, we have shear stress. On the horizontal axis, we have the normal stress. Okay, on the horizontal axis, we have normal stress. On the vertical axis, we have the shear stress. Okay,
सॉरी
and
सर ये आप स्क्रीन शेयर नहीं हो रही
with me it is sharing and it's written presenting.
सर वो हमारी साइड पे ब्लैक है
तुम्हारी वाली साइड पे ब्लैक होना है. Let me read.
सर हमारे भी नहीं आ रही. सर वो ब्लैक है नजर नहीं आ
किसी
रही.
और से भी
इंटरनेट वैसे वीक है, वरना ये होनी चाहिए. Let me reshare it. 1 second. अब आ रही है कि नहीं?
यस सर अब आ रही है.
So first of all, you have to draw the vertical and the horizontal axis. Vertical and the horizontal axis. Okay, so first is we have to draw the vertical and the horizontal axis. On the vertical you have shear stress. On the horizontal you have the normal stress. On the horizontal you have the normal stress. Now the next important thing about Mohr circle is that the scale on both x and y axis, the scale on both x and y axis, that needs to be same. ठीक है जी? So your scale on x and y-axis, it must be same. On the vertical axis, I have taken, so this is my origin, center origin of the axis 0, 0. So I have taken, because I know that the radius is 81.4, so I need to have what you say, up to 80, minimum 80. So this is 0, minus 20 megapascals, minus 40 megapascals, minus 60 megapascals, and minus 80 megapascals on shear stress axis. Then we have 20 megapascals, 40 megapascals, 60 megapascals, and 80 megapascals positive on the shear stress axis. Then on the horizontal axis, I have the normal stress, 20, 40, 60, 80, 100, and 120. On this side, I have taken minus 20, minus 40, minus 60, minus 80. You get it? Now, after you have taken, drawn the axis, and you have what you say, mark the scale. Now, next thing is you have to locate the point C. So point C is the center point of the Mohr circle. Point C is the center point of the Mohr circle, and its coordinates are 35 and 0. So on the normal stress axis, you will mark 35, and on the shear stress, it is 0. So 35, 0. So if you draw this, this average point is this point C, center point of the Mohr circle. C is the center point of the Mohr circle. So please mark the point C. G. Did you mark the point C? Point C has the coordinates 35 and 0. 35 and 0. Has the coordinates 35 and 0. So did you mark the average point, average normal stress and 0? So this is your point C. Now next thing is I have to mark the point A. Point A is minus 20 megapascals. This is 0, 0. This point is 0, 0. This point is the center point of the Mohr circle. This is the origin 0, 0. So I have to mark the reference point A. Reference point A has what you say, this coordinates minus 20 and 60. So 0, minus 20, and 60 positive. So 20, 40, 60. So this point is your reference point having the coordinates minus 20 and 60. So this is your reference point having the coordinates minus 20 and 60. Is this clear? Is this clear?
Yes, sir.
Reference point. Please mark the reference point on your graph or whatever on your register on which you are doing. So after you have marked the point A, you have the reference point A and you have the center point of the Mohr circle. So you will connect C to A. So connect C to A. ठीक है जी? So after marking the center point, ठीक है, on the Mohr center point of the Mohr circle C and the reference point A, connect C to A. Connect C to A. So you will get the radius of your Mohr circle. Radius of the Mohr circle. How many of you have done this up till this point? जी, how many of you have marked the center point C and reference point A, and then you have connected C to A? ये तो इंटरेस्ट है आपकी क्लास का। Ten people have done it. Okay. So after that, you will place your compass at point C, and you will place the compass at point C, and you will open up equal to the radius C to A. You will open up the compass up to C to A, and you will draw this Mohr circle. If you do not have the compass, then what you can do from point C, which is your reference point C, what you can see, you can plus radius in it, that is 81.4. So 35 plus 81.4 will be 116.4. So you can mark that point here. Then 35 minus 81.4, you can mark a point here. ठीक है जी? Then 30, this is 0 on the vertical axis, 0, so 81.4 downwards and 81.4 upwards. So you can mark those 4 points and then connect it with the circle. ठीक है, smooth line. ठीक है जी? So please draw this. Okay. So now next step is, after you have drawn the Mohr circle, so now next thing is, we have earlier said that on the principal planes, over shear stress value will be 0. Over the principal planes, shear stress will be 0. So you can see this over this plane, over this horizontal axis, ठीक है जी, horizontal normal stress axis, your shear stress value is 0. So it means this is over principal plane. This is over principal plane over which your shear stress is 0. Now we know that over the principal planes we have the maximum value of the normal stress and the minimum value of the normal stress. Maximum normal stress is over major principal stress, and the minimum normal stress will be over minor principal stress. So these 2 points B and D. B represents over major principal stress and it is sigma 1. D is over minor principal stress. It is negative, smaller than sigma 1. So this is designated sigma 2, and its value will be 35 minus 81.4. So what's the value you are getting? 46 point. जी क्या वैल्यू आ रही है?
46.4.
Minus 46.4. So this point represents B. This point is D. B is over major principal stress. D is over minor principal stress. ठीक है जी? So these 2 points are basically over major principal stress and minor principal stress, and these 2 points are lying over the principal plane over which your shear stress value is 0. This is the plane over which your shear stress value is 0, and your normal stress values, you have maximum and minimum value of the normal stress, major principal stress and minor principal stress. Done? Done?
Yes, sir, done.
So now next thing is we need to calculate the orientation of the principal planes. So this CA is our reference plane. C2A is your reference plane. So moving from the reference planes, ठीक है जी, moving from the reference plane towards the principal plane CB. So moving from the reference plane CA to CB, moving from the reference plane CA to CB, ठीक है जी, we will get 2 theta P1, orientation of the principal planes. So I can calculate this theta, ठीक है जी, can you calculate using trigonometry this theta, ठीक है जी, so please calculate this value of theta. So this value of theta will be tan theta over, this is what you say, this is 55, 35 and 20, 55, and this will be 60, ठीक है जी, ठीक है जी. So please calculate the value of theta, this theta. Please calculate this value of theta and let me know the answer. Tan theta 60 over 55, कितना ये, what is the value of this angle? 47.5 कर लेते हैं. So 47.5 degrees. So your 2 theta P1 is this angle. So this 2 theta P1 will be 180 degrees. 180 degrees minus 47.5. So 2 theta P1 will be 180 degrees minus 47.5. So this is coming out to be 132.5 degrees. So this is the angle of 2 theta P1. ठीक है जी, 2 theta P1 is 132.5 degrees. ठीक है जी, 132.5 degrees. So theta P1 will be, so theta P1 will be, so theta P1 will be आपका बेसिकली आएगा 66.25 डिग्रीज. ठीक है जी. Okay, now you, or if you also want to calculate 2 theta P2, so moving from the reference that plane CA in the same counterclockwise direction, you will get 2 theta P2. So this difference between 2 theta P1 and 2 theta P2 is 180 degrees. So 2 theta P2 will be equal to 2 theta P1 plus 180 degrees. So you will get the value of 2 theta P2. You will get the value of 2 theta P2. G. So what's the value? So 180 degrees plus 132 point आपका था 5. Okay, good. Now, so this is all about the principal stresses and the orientation of the principal plane. So over principal stress sigma 1 is 116.4 megapascals. Sigma 1 is 116.4 megapascals. Sigma 2 is minus 46.4 megapascals. ठीक है जी. And theta P1 is कितना है जी 66.3 और थीटा P2 कितना है 66.3 प्लस you can 156.3 degrees. Okay, now next thing is we have to calculate the maximum in plane shear stress. Maximum in plane shear stress. So we know that this point E, because our shear stress is positive downwards and negative upwards. Shear stress is in this case we are taking positive downwards, negative upwards. So the maximum value of the shear stress, which will be over maximum in plane shear stress, is this E. ठीक है जी. E is your maximum in plane shear stress. F is basically your minimum value of the shear stress. So can we calculate? We can directly get the value of the what you say maximum value of the shear stress and the minimum value of the shear stress. So maximum value of the shear stress is 81.4 megapascals, which is just exactly equal to the radius. Exactly equal to the radius. ठीक है जी. So maximum in plane shear stress is your point E, which is 81.4 megapascals, and F is your minimum value of the shear stress. So we just needed the maximum value of in plane shear stress. Now next is we want to calculate the orientation of the shear planes. We want to calculate the orientation of the shear planes. So moving from this reference plane CA, moving from this reference plane CA in the counterclockwise direction towards the plane CE, towards the plane CE. This is your plane CE. So you will get the value of 2 theta S1. One thing is 2 theta S1 will be 90 degrees minus this angle. This angle आपने 47.5 I think you guys told me 47.5. ऐसे ही है. So 2 theta S1 will be from the reference plane CA to the plane CE. So this is 2 theta S1. So what's the value of 2 theta S1?
42.5.
42.5 degrees. ठीक है जी. So then we can also calculate 2 theta S2. So moving from the reference plane CA towards CF, moving from the reference plane CA towards CF, I will get the value of 2 theta S2. ठीक है जी. So that will be basically 42.5 degrees plus 180. So this will be 222.5 degrees. ठीक है जी. Is this point clear? So you can see this from the Mohr circle. It is very simple to calculate or to get the values of principal stresses, major principal stress, minor principal stress, maximum in plane shear stress, orientation of the principal planes, orientation of the shear planes. ठीक है जी. Now next thing is we need to calculate. ठीक है जी. Let's say earlier using the equations you were asked that okay, you are given the stress state and your element is now rotated at an angle, let's say 20 degrees, 30 degrees, 40 degrees counterclockwise, and you are asked to calculate the transformed normal and shear stresses. Now in this case, you have this one. We are going to calculate transform normal and transform shear stresses at an angle of 40 degrees counterclockwise. Now we know that theta on the element will be equal to 2 theta on the Mohr circle. I repeat, theta on the element will be equal to 2 theta on the Mohr circle. So theta is 40, so 2 theta will be 80 degrees, and the sign convention will be same counterclockwise. So moving from the reference plane, CA towards CA to 80 degrees counterclockwise. ठीक है जी, आपने counterclockwise 80 degrees में ये करना है from here. Let's say this is 42.6 degrees. ठीक है जी, so approximately somewhere here in the mid, ठीक है जी, it will be 40. So 42.6 plus 39.4 should give you the 80. So you can do this measurement with the help of the protractor. And approximately I have marked this point here, P. ठीक है जी, and the coordinates of the point P I can directly get from my Mohr circle. So please do this and let me know the coordinates of your point P. Coordinates of point P.
Excuse me, sir.
जी
सर मैंने सब्जेक्ट अब रजिस्टर किया तो मुझे टीम्स में ऐड कर दे, मैं टीम्स में ऐड नहीं हूँ.
Right in the middle of the class you are saying this. You can wait it or you can text it.
सर मैंने आपको टीम में टेक्स्ट किया है सर. माइक्रोसॉफ्ट टीम.
You are already added in the class. While we are studying, you can just focus on the study. Before and after the class, you can ask this. You are already in the class. So now next thing is we want to calculate the coordinates of the transformed normal and the shear stresses. Transformed normal and the shear stresses. ठीक है जी? So please let me know the coordinates of the transformed normal and shear stresses for an angle theta which is 40 degrees counterclockwise. For an angle theta which is 40 degrees counterclockwise. Please let me know the answer. Ji, please let me know the answer of coordinates of the point P which is 80 degrees from the reference plane CA. Ji, please let me know the coordinates of point P. Okay. So did you draw this with the compass? Because that's the correct coordinates which you have got. Okay, so if you have any question about the Mohr circle, you can ask me. In this example, I used the data 9.8, but I have covered all 9.7 and the other examples because I have asked you to calculate the principal stresses, orientation of the principal planes, maximum in plane shear stresses, orientation of the shear planes. Then I have asked you to calculate transform normal and shear stresses of the point or an element which is oriented at 40 degrees counterclockwise. 40 degrees counterclockwise. ठीक है जी? Any questions about this Mohr circle? Mohr circle is quite an important topic, and if you have any questions, you can ask me. If no question, then we are going to have a break. ठीक है जी? And after the break, we will start our next topic, that is absolute maximum shear stress. So see you after the break. We will start at 2:10 exact. ठीक है जी? 2:10, and we will today we will just study over last topic as well, that is absolute maximum shear stress. If you will have any question, I am here, you can ask me now. You guys, are you guys back?
Yes, sir.
Okay. So now let's start our next topic. Sorry, I forgot to start the recording. Okay, ji. Our next topic is absolute maximum shear stress. Absolute maximum shear stress. So first I will explain to you, and then we will see the figures, and then we will read this stuff as well. So let's first give me time to explain this. So at the start, we started with triaxial stress state or general stress state. In triaxial stress state, which was three axes, x, y, and z axis. And in that case, you have said that you have three normal stresses and three shear stresses. So this was over sigma x, this was over sigma y, normal stress sigma y, this was over normal stress sigma z. So I repeat, this was sigma x, sigma y, and sigma z, normal stresses. ठीक है जी. Then this was over complementary sigma x, this was over complementary sigma y, this was over complementary sigma z, and this was over tau shear stresses. So this was tau x y, tau x z. This was tau yx, tau yz. The first subscript refers to the plane over which your shear stress is originated, and the second subscript represents the direction in which it is pointing. ठीक है जी? So now this is tau yx, tau yz. This is tau zx, tau zy. So we have basically sigma x, sigma y, and sigma z. These were over three normal stresses. Then we have shear stress tau xy, tau xy, tau xz, and tau yz. So these are three over shear stresses. ठीक है जी. So this was over triaxial stress state in three-dimensional x, y, and z planes. And then we said that in our engineering practice, we simplified this triaxial stress state to biaxial stress state. So in triaxial stress state, you have sigma maximum, sigma average, sigma minimum. ठीक है. In your biaxial stress state, plane stress state, this one, in which you have x and y plane, you have x and y plane, and in your x and y plane, you have two normal stresses, sigma x, sigma y, and you have one shear stress, tau x, y. So if you recall, this is sigma x, this is sigma y, and if I show the shear stress here, that will be tau x, y, and the other shear stress complementary will be tau y x. So we have only one shear stress, tau xy, and two normal stresses, sigma x and sigma y. So now in your biaxial stress state, you have two normal stresses, and or you can say you also have two principal stresses. So now here we are considering a figure in x and y plane, and along the z you can see there is no normal stress. So this principal stress, let's say sigma 1 is acting along x-axis, sigma 1, and sigma 2 is the other principal stress which is acting along the y-axis. ठीक है जी. So sigma 1 is acting along the x-axis, sigma 2, the other principal stress, is acting along the y-axis, and there is no stress, normal stress, acting along the z-axis in biaxial stress state. So if I split this three-dimensional figure in two dimensions, let's say first we are starting with YZ plane. ठीक है जी. YZ plane or ZY plane. You can see this. In YZ plane, you have only principal stress along the y-axis, but you don't have any principal stress along the z-axis. ठीक है. Then you have let's take x and z plane. In x and z plane, you have the normal, you have the principal stress along the x direction, that is sigma 1, but you have no principal stress about the z-axis. You have the principal stress sigma 1 along the x-axis, but you have no principal stress about the z-axis. ठीक है जी. Then we have a third scenario, x and y plane. In x and y plane, you can see along the x-axis you have sigma 1, whereas along the y-axis you have sigma 2. Along the x-axis, we have sigma 1, whereas along the y-axis we have sigma 2. So everyone agrees with these three possible figures, B, C, and D. ठीक है जी. So we have this plane stress, biaxial stress state, and we have split this biaxial stress state into uh, one plane xy. We have zy, zx, and we have xy planes. Everyone agree with these three figures? If you agree with these three, then we will proceed further.
Yes.
Okay. Okay, now we will draw the Mohr circle corresponding to each element. ठीक है जी? So figure B, C, and D. We have three figures corresponding to each one. We will draw the Mohr circle. So let's start first with this one. This YZ plane. In YZ plane, you have an element on which there is principal stress sigma 2, but there is no stress over Z. So 0 and sigma 2. So always remember sigma 1 is the larger principal stress, whereas sigma 2 is the smaller principal stress. Sigma 1 is the larger principal stress, sigma 2 is the smaller principal stress. And this is the case, sorry, I did not tell you here, that this sigma 1 and sigma 2, they are both tensile stresses. Because they both are trying to produce the elongation in the element. So stresses which produce elongation in the element, you can see this sigma 1, sigma 1, sigma 2, sigma 2. So both are positive in nature. Positive tensile stresses, so they are trying to produce elongation in the element. So both stresses sigma 1 and sigma 2 are positive, but sigma 1 is larger, sigma 2 is smaller. So corresponding to sigma 2, so we have drawn this Mohr circle. So this Mohr circle is drawn. Everyone can see this smaller Mohr circle, 0 to sigma 2. ठीक है जी? So one principal stress is 0, other principal stress is sigma 2. So this is over Mohr circle for that, and this is your maximum in plane shear stress for this top y dash z dash. Y dash z dash. Why top y dash z dash? Because you are drawing the Mohr circle against this element. Okay? No principal stress above the z axis, but along the y axis you have sigma 2. Fine. So this Mohr circle 0 to sigma 2, this smaller Mohr circle represents your case D, and the in plane shear stress tau y dash z dash. So this is the dia. So sigma 2 minus 0 will give you the dia sigma 2. So radius will be sigma 2 over 2. So this is your in plane shear stress tau y dash z dash maximum. This point is this point clear?
Yes, sir.
Okay. Then you have second case x and z. In x and z, you have sigma 1 and other principal stress is 0. So if you see this outer bigger Mohr circle, so this outer bigger Mohr circle 0 and sigma 1, this one 0 to sigma 1, this outer one 0 to sigma 1, 0 to sigma 1. So in plane shear stress will be sigma 1 minus 0 over 2, this one tau x dash z dash. This is representing this outer circle. ठीक है जी? 0 to sigma 1 is this outer circle, and this is your maximum in plane shear stress tau x dash z dash. ठीक है जी? So this is sigma 1 over 2. Agree with this second Mohr circle? Agree with this?
Yes, sir.
Okay. Now you have this third element, x, y. In x, you have sigma 1. In y, you have sigma 2. So when I represent this on Mohr circle, I will get this Mohr circle. Sigma 1, major principal stress, sigma 2, the minor principal stress. And the maximum in plane shear stress will be sigma 1 minus sigma 2 over 2. ठीक है जी? So you will get the radius, which is maximum in plane shear stress, tau x dash y dash. So this is tau x dash y dash. ठीक है जी? tau x dash y dash. Agree? Agree जी?
Yes, sir.
Okay, so now you have three Mohr circles. So this one is maximum, this is maximum in plane shear stress tau y dash z dash. This is tau x dash y dash, and this is tau x dash z dash. Now the next thing is we want to calculate. These are individual in plane shear stresses. These are individual in plane shear stresses. So what we want to calculate, absolute maximum shear stress. Now you have three in plane shear stresses. This one tau y dash z dash, tau x dash z dash, tau x dash y dash. So we have three in plane shear stresses. So the largest of the three, ठीक है जी, that will be your absolute maximum shear stress. That will be your absolute maximum shear stress. So this one, the largest of the three, tau x dash z dash, in this case is your absolute maximum shear stress. Absolute maximum shear stress. Fine. ठीक है जी? So tau x dash z dash, which is basically sigma 1 over 2. So that is your absolute maximum shear stress, sigma 1 over 2. Is this point clear? If you have any question, ask me now. Okay, now next thing is we want to calculate the maximum in plane shear stress. We want to calculate the maximum in plane shear stress. ठीक है जी? So maximum in plane shear stress is the one which includes both sigma 1 and sigma 2. So maximum in plane shear stress is the one which includes both sigma 1 and sigma 2. So our maximum in plane shear stress will be the one which includes both sigma 1 and sigma 2. So this one, tau x dash y dash, will be your maximum in plane shear stress, and this is your absolute maximum shear stress. Is this point clear? So this was the case in which both your principal stresses were positive. Now, in case if both of your principal stresses are negative, then whole of this figure will be shifted to the left hand side, but your absolute maximum shear stress and maximum in plane shear stress, they will remain same. They will remain same. Is this point clear? They will remain same. The other scenario is the second scenario. This is the second scenario. In the second scenario, one of the principal stresses is positive and the other one is negative. Sigma 1 is positive as it is tensile in nature, whereas sigma 2 is negative. ठीक है जी? It is compressive in nature. So when we will draw the figures, sigma 1 is positive, sigma 2 is negative. ठीक है जी? So when we will draw the figure, we will get sigma 2, this Mohr circle on the negative side, sigma 1 positive Mohr circle on this positive side, and then the third case, x and y plane. So you will get this outer Mohr circle, and in this case, this outer Mohr circle, which will have this maximum in plane shear stress, will give you the absolute maximum shear stress, and it will also give you the maximum in plane shear stress because it will include both. Uh, it will include both what you say sigma 1 and sigma 2. ठीक है जी? In the second scenario, where when you will have both when you will have one principal stress positive and other principal stress negative, in that case your absolute maximum shear stress and maximum in plane shear stress, they will be same. Any questions? Any questions? If no questions, then let me repeat it because there are a few things. So this you can see when a body, when a point in a body is subjected to three-dimensional state of stress, an element of material has normal stress and two stress components acting on each of the faces. That we have said, let's say on the x face, you have sigma x and tau xy and tau xz. On the y face, you have sigma y and tau yx and tau yz. On the z face, you have sigma z and tau zx and tau zy. ठीक है जी? Like in the case of the plane stress. In the case of plane stress, we have basically now when we say plane stress, we are basically saying x and y plane. So we have two normal stresses and one shear stress. So like that, in case of plane stress, it is possible to develop stress transformation equations that can be used to determine normal and shear stress components acting on any skewed plane of the elements for any given orientation theta. Okay, you can calculate the transform normal and shear stresses. Okay, then further at the point, it is also possible to determine the unique orientation of element. Unique orientation of element is basically your orientation of the principal planes over which you will have principal stresses. So at the point, it is also possible to determine the unique orientation of an element having only principal stresses acting on its faces. ठीक है जी? So in general, these principal stresses will have, in case of triaxial or general state of stress, you have sigma maximum, or you can say major principal stress, minor principal stress, and also intermediate principal stresses. So this was triaxial stress state, but because we did not study this in detail, we just studied the basic working principle of the triaxial stress. Over focus was on over biaxial stress state, or you can say the plane stress state. So in case of plane stress state, you have x and y plane, you have two normal stresses, two principal stresses, and you can say you have two normal stresses, one shear stress, so you will have two principal stresses. ठीक है जी? It to be subjected in the plane principal stresses sigma 1 and sigma 2, this one. So in this given condition, both were positive, both were tensile in nature. ठीक है जी? So you have split this three-dimensional element into two-dimensional. ठीक है? In x, y plane, in yz, xz planes, and you got these three figures. And corresponding to those three figures, you have drawn this Mohr circle. ठीक है जी? If we view the element in two dimension, so if we view the element in two dimensions, ठीक है जी? So you will get these three elements, and corresponding you will have this Mohr circle. Now, how to get? They are now explaining it. We can use Mohr circle to determine the maximum in plane shear for each case, and from this determine the absolute maximum shear stress in the material. For example, the diameter of the Mohr circle extends between 0 and sigma 2. So this is this case, YZ case. Then again, they are repeating the same for XZ case and XY case. So in case when you have both the principal stresses either positive or negative, your absolute maximum shear stress will be tau x dash z dash, that will be sigma 1 over 2, and your maximum in plane shear stress will be this one, sigma 1 minus sigma 2 over 2. And in the second scenario, when one of the principal stress is negative, other principal stress is positive. ठीक है जी, one of the principal stress is negative and other of the principal stress is positive, you will get this figure. ठीक है जी, sigma 2 is negative, so 0 to sigma 2. Sigma 1 is positive, so 0 to sigma 1. Always remember, this case will remain the same because over larger principal stress will always be sigma 1 and over smaller principal stress will always be sigma 2. So then we have this outer Mohr circle. This is sigma 1 to sigma 2. ठीक है जी, and in this case you will have maximum in plane shear stress and absolute maximum shear stress as same values. ठीक है जी, which is sigma 1 minus sigma 2 over 2. So absolute maximum and maximum in plane shear stress values, they will be same. Any questions? Any questions? No questions? Great. इसका मतलब कि you guys are understanding everything. And of course, at the end of the topic, I think it's good that people are getting the stuff. Okay, now I have drawn the figures and I will share those figures with you. ठीक है जी, so this is the case one in which both of your stresses, principal stresses sigma 1 and sigma 2 have the same sign. In this case they are positive, so first you have to draw this three-dimensional figure in two-dimensional. You have to show yz, xz, and you can see in case of yz you only have sigma 2, whereas in case of xz you only have sigma 1, and in case of xy you have sigma 1 and sigma 2. You have sigma 1 and sigma 2. ठीक है जी, now in this case we are going to draw the Mohr circle 0 to sigma 2 corresponding to y and z. So tau dash tau y dash z dash, then corresponding to xz 0 to sigma 1, this outer Mohr circle 0 to sigma 1, this outer. ठीक है जी, and this one is tau x dash z dash, and this is equal to sigma 1 over 2. Then the third one will be x and y. In case of this x and y, you have both sigma 1 and sigma 2. So this Mohr circle will explain this. ठीक है जी, so this Mohr circle will explain this sigma 1 to sigma 2. ठीक है जी, and this tau x dash y dash will be the what you say in plane shear stress for this Mohr circle. ठीक है, for this case x and y, and this will be over maximum in plane shear stress, and the larger of the three will be your absolute maximum shear stress. So in case where you have sigma 1 principal stresses have the both sign, in that case you have absolute maximum shear stress as sigma 1 over 2, this one, okay, this one sigma 1 over 2, and your maximum in plane shear stress will include sigma 1 and sigma 2, so sigma 1 minus sigma 2 over 2. Is this point clear? Is this point clear? Okay, then comes the second scenario in which one of the principal stress is positive and other principal stress is negative. So this is the case now. The second one, that sigma 1 and sigma 2 principal stresses have different signs. So this is sigma 1 positive, this is sigma 2 negative because it is compressive. So when we will draw these figures on so now when we will draw this figure YZ plane, you have sigma 2. In XY plane, XZ plane, you have sigma 1. Whereas in case of XY, you have sigma 1 and sigma 2. The difference over here is that in this case, sigma 2 is compressive, so you can see it is pointing inwards. Sigma 2 is compressive, you can see it is pointing inwards. Okay, ji, so now corresponding to this, you will draw the Mohr circle. So this is negative. So principal stress about Zx is 0. So 0 to sigma 2. So this one, this smaller Mohr circle. Tau y dash z dash having maximum in plane shear stress sigma 2 over 2. Then you have this xz in which you have principal stress about zx is 0, about x you have sigma 1. So 0 to sigma 1. By mistake it's written sigma 2, it is sigma 1. So 0 to sigma 1, you will get this Mohr circle, and it is tau x dash z dash that will give you the in plane shear stress for this Mohr circle. Third one is this x and y in which you have sigma 2 and sigma 1. So we are just going to draw this Mohr circle encapsulating basically sigma 1 and sigma 2, and its maximum in its in plane shear stress will be this one, tau x dash y dash. Now in this case, absolute maximum shear stress, the larger of the three, is this tau x dash y dash, and the maximum in plane shear stress, which includes both sigma 2 and sigma 1, is also the same. So absolute maximum shear stress and maximum in plane shear stress, they will be the same formula, sigma 1 minus sigma 2 over 2. Is this clear?
Yes, sir.
Yes, sir, clear है.
ठीक है, now we will do a numerical. Let me share the okay. Now this is the question. Now, this is the question. The point on the surface of the cylindrical pressure vessel, this is shown, and is subject to the state of the plane stress. Okay, and they have given you the principal stresses, 32 megapascals and 16 megapascals. Okay, now you are required to calculate the absolute maximum shear stress. So very simple. In this case, both stresses are positive, tensile in nature. So larger principal stress will be sigma 1 and the smaller principal stress will be sigma 2. So sigma 1 we have 32 megapascals, and sigma 2 we have 16 megapascals. Okay, ji? So first we have to draw the figures. So you have to draw the figures in the plane xy, not xy. First go with yz, then xz, and then xy. ठीक है जी? And then you can draw this Mohr circles. ठीक है? So this one is basically you can say yz 0 sigma 2. ठीक है जी? Sigma 2 is 16. So tau yz dash is 8 megapascals. This one. Then you have to draw for tau x for xz. In xz you have you have principal stress 32 megapascals and 0 to 32, and the radius will be sigma 1 over 2, that is 16 megapascals. ठीक है जी? Then we will draw xy. in xy, we will connect sigma 1 with sigma 2. So this will be sigma 1 minus sigma 2. 32 minus 16 is 16. So its radius will be 8 megapascals. So absolute maximum shear stress will be 16 megapascals and maximum in plane shear stress will be 8 megapascals. Is this question clear? If you have any query, please ask me. Clear?
Just like that.
Okay. If this is clear, in exam, if such question will come, it will come in like last step of the question that you have to calculate absolute maximum shear stress. So you will be using the values of the principal stresses which you have calculated, sigma 1 and sigma 2. Okay? So, let me. So with this, our chapter stress transformation is complete. Okay, over this chapter stress transformation is complete. So from next time, Dr. Numan will take your classes, and after I think we will have 7 weeks. So 3.5 weeks you will study shear center with Dr. Numan, and the last 3.5 weeks you will study what you say this strain transformation with me. ठीक है जी? And let me stop the recording. ठीक है? So that's it from my side for today. And if you have any queries, please ask me. If you have any query, please ask me. If no query, then let me know that tomorrow there will be no class, 1 hour class. I will take this class next time when I will start strain transformation with you guys. So for the time being, our stress transformation chapter is finished and we are exactly at the midway. So there is possibility that you may have 8 weeks for the teaching or 7 weeks. Because what you say, you have 1 week of you have 1 week holidays because of Eid. So maybe you may have 7 weeks more or 8 weeks more. I'm not too clear. I asked the department, so we are waiting for the decision from Director Studies. So if there will be 8 weeks, then we will have a good time to complete strain transformation in 4 weeks, otherwise 3.5 weeks. Okay, so tomorrow there will be no class. I will rearrange this class in the 13th week when I will start with you guys strain transformation. Any questions from your side? I will share the lecture and figures and also the practice problem with you in 2 days time, and then you can start this. Yes, any questions from your side?
Excuse me, sir.
जी
Excuse me, sir.
जी
सर आपने मुझे टीम्स में ऐड किया लेकिन मेरे पास मेल नहीं आया.
चले, मैंने तो ऐड कर दिया था. अब डॉक्टर नुमान को कहना है क्योंकि आप लोगों ने अब नेक्स्ट वीक से जाना है.
ओके सर, मैं उनको बोलूंगा वो ऐड कर देंगे. ठीक है.
If there is no question, then guys, thank you very much for your time. I will catch up with you guys during the lab classes. ठीक है जी? And Dr. Numan will take the classes according to his schedule. So inshallah, I will see you on Mondays and on Wednesdays. ठीक है जी? So we have done like most you can say around 55 to 60% of our experiments. So rest we will continue in our lab, and most probably you guys will have 2 weeks on campus psychomotor performance. And during that psychomotor performance, we will have the quizzes, we will have lab evaluation. If no questions, guys, thank you very much for your time and see you soon on Monday.